आज हम लोग देखेंगे कंडक्शन के ऊपर एक न्यूमेरिकल। तो क्वेश्चन जो है वो ऐसे है, स्टेनलेस स्टील प्लेट 2 सेंटीमीटर थिक is maintained at a temperature of 550 degrees centigrade at one face and 50 degrees centigrade on the other. So I have drawn a plate where one face having the temperature of 550 and other plate have the temperature of 50 degrees centigrade. The thermal conductivity of the stainless steel at 300 degrees centigrade is 19.1 watt per meter Kelvin. Compute heat flow through the material per unit area. So what we have to do, we have to compute the heat flow. So here the temperature is higher. The temperature of this side is 550 degrees centigrade and this side temperature is 50 degrees centigrade. So what we are saying that the temperature decreases from this side to this side. Okay, so heat flow will be from higher to lower side. And suppose this is a thick plate and x is equal to 0 here and x is equals to L here. L is the thickness of the plate. So what we do that we apply the Fourier law. We know that the Fourier law is basically Q equals to minus Ka dt upon dx. So if you see the formula, then put dx this side, then it becomes qx multiplied dx equals to minus Ka into dt. And when we integrate over the limit of x equals to 0 to x equals to L, then the temperature will become T naught this side and TL this side. So this side the temperature interval will be from T naught to TL as we change x from 0 to L. Then we integrate the things, then dx become x, so it becomes L minus 0 and this side becomes TL minus T naught and minus sign is there. So minus sign when we take, so minus multiplied by this, it becomes Ka T naught minus TL divided by L. So overall temperature heat flow will be thermal conductivity of the material multiplied by the area. Qx is equals to Ka T naught minus TL. So K is thermal conductivity of the material, area is this one, this area perpendicular to the heat flow, T naught is higher temperature, TL is the lower temperature and L is this length. So we can use this equation directly. So this is given, but here the question is like we have to find out the heat flow through the material per unit area. So what we do that we take this area this side, so it becomes Qx upon it, that becomes a heat flux. So we have to calculate the heat flux of the material, that is equal to K into this divided by L. So now if we put the values, so you can put the values and find out this value. So K value is given as 19.1 watt per meter Kelvin and length value is given as 2 centimeter. So converting the meter, okay, and this temperature is in 550 degrees centigrade and 250 degrees. So it can be written as 550 plus temperature. So T naught will be 550 plus 273. Okay, so this value we can substitute here, and similarly TL value will be 50 plus 273. So if we subtract these two values, then 273 will be directly cancelled out. So finally it will be 550 minus 50 only. Okay, so it becomes 100. So the final answer will be like this: 19.1 into 500 divided by 0.02. So you can take this side 100 and this side and 10, and it will be getting crossed off. And when you do this thing, then 19.5 into this value, the overall value will be possible. अब हम लोग देखने जा रहे हैं कंबाइंड इफेक्ट ऑफ हीट ट्रांसफर। तो ये एक सॉलिड ऑब्जेक्ट है, ये सॉलिड ऑब्जेक्ट रखा हुआ है, इसके लेफ्ट हैंड साइड में एक फ्लूइड है और राइट हैंड साइड में दूसरा फ्लूइड है। तो लेफ्ट हैंड साइड का फ्लूइड अगर आपका ये है और राइट हैंड साइड का फ्लूइड अगर आपका ये है, तो ये दो फ्लूइड्स हैं। तो दोनों के केस में क्या हो रहा है, बेसिकली दिस इज TA एंड दिस इज TB एंड TA इज ग्रेटर देन TB। So what is happening, that the heat flow is taking from this side to that side. So overall what we see, that overall heat transfer will be Q equals to UA delta T. So this is overall heat transfer coefficient, and A is the area and delta T is the temperature difference, that is TA minus TB. Okay, so this is the thing. But if we are seeing here that this is the combined mechanism of heat transfer, like here convection is going on, here convection is going on, and here conduction is going on. So all these three effect will be there for getting heat transfer. So overall heat transfer rate can be determined by three things. One is the Q convection, one Q conduction, and Q convection 2. So this is convection 1, convection 2, this is the conduction. So for Q you can write convection, it can be written as H1, this is heat transfer coefficient H1 into area, this area, and multiplied by temperature difference, that is TA minus T1. Next, for conduction we know that it is Ka by L. K by L multiplied by temperature difference, that is T1 minus T2. This is the, what is T1 and what is T2? T1 is the temperature of this surface, T2 is the temperature of this surface. So this is the intermediate temperature which directly it can be measured. Okay, so this is the T1 and this is the T2 of the interface. Okay, next is H2 into A multiplied by T2 minus TB. So what is happening, that we are having three equations. So this is of convection, this is of conduction, and this is of again convection. Next, for deriving the formula, what we do, that we take first these two, next we will take this and this, and lastly we will take these first and last one. So when we take first one with this this term, Q with this term, then it becomes TA minus T1 equals to Q upon H1 into A. Similarly, if we say, so we can put this equation 1, this equals to this, so it can be written as T1 minus T2 equals to Q upon Ka by L. This is equation number 2, and third it can be written as T2 minus Tb equals to Q upon H2A. So this is the third equation. So next what we do, that we will add all these three. So when we add these three, then this will get cancelled, this will get cancelled, then ultimately we are getting Ta minus Tb. So adding all these three, we can get Ta minus Tb. Next is Q will get common in all these, then it will be 1 upon H1A plus L will come in the numerator part, it will be L upon Ka plus 1 upon H2A. So this will be Q Ta minus Tb upon, next is this term. So this term it can be written as overall resistance. So overall resistance if we write, so we can resistance overall. So this is the overall resistance. Overall resistance is the resistance of the convection effect, resistance of the conduction effect, and resistance of the convection effect of the second fluid. So we can know that Q equals to delta T, Ta minus Tb. Ta, what is Ta minus Tb? Ta minus Tb is basically the temperature difference. Temperature difference is the driving force of this. So when we know V equals to IR, then we can write V equals to IR. Then I is basically V by R. Here what is happening? Here in place of I, we can see Q is there in heat transfer. If for electrical part we can see heat current will be voltage difference by resistance. Here in place of voltage it is temperature difference. So basically this is delta T and resistance is the same, not same, but here resistance is this value. Two convection and one conduction resistance is there. So overall heat flow can be calculated by this formula, that T1 minus Ta minus Tb divided by R overall. R overall value can be written as this: 1 upon H1A plus L upon Ka plus 1 upon H2A. Okay, so we can finish this point here only. That is known as combined mechanism of heat transfer. Okay, thank you.